So what we're actually going to do, one reason I do this, so we finished chapter 9. We did talk about that one section in 10 a little bit. It was an extra credit. And the reason I skip 11 for a minute and go to 12 is really just a thing about, would you guys like a break from hypothesis test kind of related stuff?
Yes.
Oh yeah, interesting. Would you rather learn and get a brand new chart like the Z and T score charts, or would you rather not do that immediately?
No.
You want a new chart and talk about no? I would think not. So that's why I do chapter 12 first, because it's sort of like a little bit of a break, because this is the one chapter that I will allow you to let the calculator do a bulk of the calculations. Right? So some of you guys know that I am one of the weird ass teachers that don't let you just push buttons to get numbers. Because I have this weird idea that you should be connected to what the hell you're doing a little bit more. But chapter 12 is in one place, and I'm going to show you what the formula would look like, just to kind of show you why I'm giving you a bit of a break. But here's the idea. Have you guys ever heard of something called correlation? Two things might be correlated.
Yeah.
Can somebody tell me like a rough idea what that means if two things are correlated?
Like two things can happen at the same time, but that doesn't mean that they're connected to one another.
Okay. And a little bit more, I like the thing about if two things are correlated, it does not mean that either one causes the other one. So correlation is sort of like we happen to notice that, for example, why is it not surprising that there would be no correlation between the number of DVDs somebody owns and the number of coffees they drink per day? Is there some fundamental reason those should be correlated?
No.
Right? You don't buy more DVDs and go, oh man, I need me some coffee. Or vice versa, drink some coffee, like, I gotta get me some DVDs. And some of you guys are like, okay, I just realized that I'm dating myself with DVDs. Yes, streaming, Jeff, but there are people still with DVDs, they still go out there and get them. There's still people like me that go get actual books. So, there should be no correlation between these two. This one is the opposite end of the spectrum. This one is an obvious correlation. This is age in months versus height of a human, right? Human baby. So, as the kid grows older, they should also grow taller. But of course, why isn't this a straight line?
Because correlation does not equal causation.
More talking about age and height. Does everybody grow at the same pace? Does everybody grow to be the same height at the end?
No.
No. In fact, do any of you have children that you want to let me know? No. Do any of you know about the height and weight graphs that sort of like look like this here? They have this line down the middle. Sort of looks like a hurricane track. So somewhere, so this would be like if your kid was right there for height, that would be like the 99th percentile of height. So normal, if this is at a certain age, and this is a height, and this is like containing where people normally should show up. So if somebody was here, that would be a big time outlier, yes? So one of my friends, they named their kid Max, and a few months later, he was at the 99th percentile height, and the 90-something percentile weight. And I'm like, you named this kid so well. And that was like freaking huge. Anyway, so that's that. This one is almost too obvious. Yes, do you guys agree with me? Mm-hmm. Almost too obvious. Even if there's somebody who's never going to be very tall at all, so they're sort of like hanging out here, even at this age, there's still a definite trend. Yes. What about this? Is there a trend in this measles plot of points? No. Okay. So correlation captures a trend in a graph of data points. That has nothing to do with causation. right? It doesn't mean that. Now, in this case, do I get older because I get taller, or do I get taller because I get older?
Taller.
Yeah, of course. Okay, so that one we know. We don't need a major study on that. We just needed enough observations to go, interesting, right? Thank God it's not the other way around. Good evening. Listen. Okay, so that's pretty straightforward stuff. But let's get this idea going a little bit better. Would you say that this is a very strong correlation? What would your immediate reaction be?
No.
I got one person shaking their head yes and somebody saying no. It is sort of a subjective thing. What would strong mean? If there was going to be a strong correlation, what should be true about the picture? What do you think?
I think the dots would hug closer to the line.
All right, so there is a trend line. This may be roughly like this. And the dots are not very close to the trend line. They're not crazy far off. Yes? You with me a little bit? All right, so let me give you some better pictures instead of, I've got some pictures that I made with a computer. Let's talk about drinking beer, taking tests. This is going to be the first example.
Hoorah!
Yay, baby. There. So take a look here at this, by the way, my disclaimer at the beginning of this. This is not a suggestion for a experiment to run, okay? Just in case something happens and my dean's like, the kid said you're supposed to go get drunk the night before. No, Dean, no. It's caught on film. Okay. So, where are you? There. All right, let's take a look here. Oh shit. Oh yeah, you gotta turn it off. That's crazy. These machines are so needy. Yeah. Turn it off. It's crazy. Turn the sun off. So I've got basically the same kind of questions here. And again, I'm going to talk a little about this. This was not quite as clear cut. So I don't have a specific scale, which means it would be a bad graph to turn into me. Yes? This would be a sucky graph to try to turn into me. It's not the point. You get the general idea. The point of this one is just to show the trend line. So they both have the same kind of trend, yes? What are they both showing?
A downward slope.
Downward trend. And of course, why would that kind of make sense? And notice this is a 7 a.m. class. So let's say you go out drinking, about 2 a.m., you leave, go home, you pass out, you get up, go to class, you're going to be feeling good? No. Okay, so could your performance be affected by that?
Yeah.
Yes, okay. So they both kind of show that there is a relationship between the grade that was made on the test and the number of beers somebody had the night before. This does not tell me there's a causal relationship. And somebody might argue, obviously, it seems like I'm trying to say, don't drink, kids, because it'll make your grades go down. Yeah, it depends on how well you hold your liquor, but it could also be the other way around, correct? If somebody's going to make a bad grade, maybe they've been making bad grades, and they want to kind of forget about it. Okay. So the relationship, what is causing what, is not always so clear cut. And in fact, let me tell you this. And by the way, I apologize if anyone's having trouble with alcohol. I'm obviously not making fun of alcoholism and all that kind of stuff. But it is a known fact that if teachers salaries increase, liquor sales also go up. That is a known fact. It is. What does that mean? Does that mean anything? So tell me this. If teacher salaries go up, what else probably happened? No, come on.
Oh, they get rid of staff?
No, come on. If teachers' salaries went up, and we work for the government, more than likely anybody else who works for the government in other positions also had a pay increase, yes? So I could have said librarian salaries go up and liquor sales go up, yes? Now you can imagine, can you think for a second? Have you ever heard something like this on like a news thing or something? So I'm not saying anybody's ever been this blunt about it, but this is one way to kind of spin something without actually just saying teachers drink all the damn time. Not all the time. All right. You with me? Okay, maybe a little bit? All right. So I don't necessarily know if one of these causes the other or if there's some third thing that's causing both of them to change. I don't know. All this kind of test can do is say there seems to be a connection here. It could totally be a coincidence. Or it could actually mean one is causing the other, or it could mean some third thing is causing both. Okay, maybe. Which one of these obviously is a stronger correlation?
On the right.
Yeah, this is obviously stronger, and exactly what you said earlier. How do I tell the strength? Well, the closer the data points are to the trend, the stronger the trend is. And that only makes sense. If I think there's a trend and some of the dots are bucking the trend, it's not a very strong trend. But if all the dots are lining up along that trend, that's a strong-ass trend. Okay, I like it. So there's going to be two things that we are going to need to be able to calculate. What do you guys think those two things are? I mean, what just came up in our discussion? How did we figure out how strong the trend was? How strong the correlation was?
Distance from a trend line.
Distance from a line, yes? Shouldn't we have to be able to calculate the line then? Okay, all right. Before you get too worried, we're not going to be doing algebra kind of stuff, yes? Remember y minus y1 equals mx minus x1, or y equals mx plus b? Yay! Okay, no, we're not going to be necessarily doing a lot of that. The first section in chapter 12 does have some review of that, which is good. So one thing I have to be able to calculate is what's called the line of best fit, which only makes sense. The line that best fits the data. The other thing I want to calculate is the other thing that came up. I want a number that tells me how strong the relationship is. What number do you think it should get if it's got no strength? If there's that like this. What number should this get that represents strength? 0, of course, and thank God it does. Yay! Okay, so we're going to talk about the number that represents how strong the correlation is, and the equation that represents the trend that we see. Okay, I like it. Now, this was the stronger relationship. Which one is more true to life?
Is there a right answer?
There is.
Left.
I mean, who is this person here? Did they drink a lot, relatively?
No.
No. Did they do well?
No.
No. So, were they probably going to do poorly anyway? Okay. So, probably no matter how much they drank, they would have been about right here. What about this person? And by the way, why did I point that out and I'm about to point this one out? What are these two? Outliers. Okay, I like it. So what's that other outlier story? They drank the most, yes? Didn't they drink the most? But they made like the 4th about highest grade, yes? So that's somebody who doesn't get a strong hangover or whatever. Okay. Maybe. All right, I'm going to stop talking about alcohol, I promise. And by the way, I could try to draw in here now this one is pretty easy. I got pretty close. can actually, in this one, I can kind of eyeball it, and maybe it would be like this. So what do you think I'm trying to do? I did okay, I guess. What do you think a line that I draw, I'm trying to make it do to be the right line? So we're going to calculate through the calculator. We're going to get the exact right line. But what do you think I was trying to do here? I mean, did it really matter? As long, like, would it be okay if it was here? All the way over here, Jeff. Ah, is that good?
No.
Is that a good line of best fit? No. So what am I trying to do as I draw the line?
Get it in the middle.
In the middle of what?
The dots.
Which dots?
Where the most dots are.
All of them. So I love this idea. I really want this to make sense. The line is like a two-dimensional graphical average. It kind of averages where all the dots are. Yes? So when I draw it, what I'm trying to do is minimize how far all the dots are away from the line. So that's why this line here is dumb, because it got closer to one dot, but it got very far away from all the other ones, so it's not a good candidate. Okay, maybe. So this one's also called the least squares line. Okay, that's funkadelic. It's better known as the best fit line, or the line of best fit. The reason it's called the least squares line, do you remember when we were doing standard deviation, we had to figure out the distance? So we did x minus x bar, and then we had to square it because some were negatives. So we do the same thing here. We would square all the distances. So this is the line that has the smallest squared distance to all the points. So we just call it the least squares line. We're going to call it the line of best fit, just because that's a little less funkadelic. Okay. So here we go. Hours studied versus grade on the test. I'm going to bring up something I just realized. I've been using this worksheet. When I got the job here, I had to send a video in of a lecture I gave. The video I sent was this lecture. And one of my colleagues said later, yeah, we like that you talked about here. So yeah, that makes you feel even better that I'm teaching. I'm going to say something here in a minute that I have never thought about until now. Same questions as before first. Which one's obviously stronger? Yeah, this guy's stronger because it's tighter to the line, and so this one's weaker. Which one's more real life?
Right.
Yeah, this one's more real life because, for example, here's the person that at least says that they studied a lot, and what I normally find out is they don't know what study means, right? I studied a lot. What'd you do? Okay, well. So this person apparently studied a lot, but didn't make a very high grade. And there's the other sort of outlier there. This is the person that barely cracked the book, but still scored a high grade. What's true about that person? Probably
Higher retainment. Is it good retainment?
good retainment, maybe, or they took the class before, right? Or who knows? Maybe they're just naturally good at whatever this is, like everybody else in my painting class. But it took a while back. Okay. Now the thing I want to say here is, what else might explain this person? What if they did study? They totally studied.
They went out and drank.
There we go. I love it. That's the one I never really made that connection. The level of analysis we're going to do can only take two things at a time. How many variables affect the grade somebody makes on the test?
Millions.
Holy shit. Our mental state. Well, what affects our mental state? Tons of stuff, right? You could be happy, and then some jackass cuts you off, and you're like, God, and you come in the room, and you're like, God. All right. So the unfortunate thing about this test is it can only analyze the how two variables at a time interact. There's a more complicated, not complicated, but more robust test called an ANOVA. And then there's another one we're actually going to get to called a goodness of fit test. That's going to be back in chapter 11. There are other tests that can handle multiple things at a time. This one can only handle 2 variables at a time. Okay. So we are going to talk about the strength number. So we're going to want to calculate a number that tells me how strong the relationship is. And that thing is called the correlation coefficient or the Pearson product. None of those words start with the letter R, so we use the letter R to represent that. Sorry, it's just the way it is. Math, yeah. Why? Reasons. Which reasons? Math. So, if R is 0, what do you think that means? We already talked about this.
That it's not strong.
No. Not even just not strong.
They're not correlated.
It's just not correlated. It's definitely not correlated. Right? R equals 0 means there appears to be no linear correlation whatsoever. So let me ask you this. R can be between -1 and 1. Which one of these do you believe is closer to -1?
The top right.
Yeah, so this is beautiful. Negative means slope negative. Right? And -1 would mean perfect negative. So if I had an R equal -1 graph, it would look like something like this. They all line up perfectly on a line. And of course, R equals 1, same idea, just positive. Make this bigger, maybe. Okay, so if I had to take a guess, I would think that this might be -0.9. You guys understand? I don't know if that's right, but I mean, it's not 1, it's not -1, because they're not perfectly lined up, but they're pretty damn close, so maybe -0.9. Give me a guess for this one.
Or what one?
This one. What'd you say earlier? It's not very strong, right?
-0.2.
Good, all right. It just has to be something closer to 0, of course, right? I mean, that one, we can still see the trend, especially if we take out the outliers, but it's pretty well all over the place when you include them. Okay, maybe. While I'm talking about this, hopefully that comic that's on your grade sheet summary makes more sense. Blah, 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 blah. Okay, so let me show you something that I should have looked up earlier, but oh well. Here we go. I'm going to show you the equation for R. Maybe I will someday. Let's see if I can remember. Ooh, there it is. Now, I think this is a beautiful equation, and that's because I'm weird. Do you guys see anything that looks at all familiar?
The sum.
Some of x
Good.
times y.
Yeah.
And some of x times y.
Yeah.
And
See a lot of shit. And one thing I want to talk about, let me stay up there, I guess. I need paper. Real quick, I want to talk. This is the equation that we would use if I was just a little more equal. We're going to do this in the calculator, but I want to remind you, just hang out for a second. Pay attention. Here we go. I'm going to show you something real quick. Remember this thing? I know. Oh, there it is. I really see. Oh, I see. There we go. Yes? Okay. Hopefully. Do you remember when we had the XP of X shit and we did some algebra to it? Does anyone remember that? We did some algebra to it, we foiled and rewrote it. Even if you don't remember it, we did. I could do something similar here. Oh, Jeff, you haven't written this in forever. Oh, this will be exciting. Let's see if I can remember. I can get a little bit of a hint. Oh, yeah. It's something like this. No, not n minus 1, John. So I can kind of foil this out and do some other mess to it, and eventually I can make it look like this, and don't hold me to this 100% because I haven't read that equation in a long time. But do you see how, if I multiply this n up, do you see how it's basically, now I've lost there. This is like the x standard deviation.
Yes.
If I divided this by n squared, wouldn't I get this?
Progressively doubling it, yes.
If I multiply this side by n squared, wouldn't I get another n in here, so it would look like this? I think I left something out, but I got pretty close. So this is related to the x standard deviation, and this is related to the y standard deviation. Now, why are they both showing up in this equation? Because when I'm plotting a point, how many parts does it have? An x part and a y part, of course, right? So now our data is going to be ordered pairs. So our data could be number of beers, comma, grade on the test. X, Y. So the beautiful thing about this, the line of best fit is like a visual average of the data. R is like the standard deviation. Not really, it kind of captures the standard deviation. If R is 0, the points do not deviate at all from the line. You guys follow a little bit? Maybe a little bit? Not at all? You guys are like, please let this end? Too bad. So it kind of makes sense that in the equation for something that should represent two-dimensional standard deviation, we see pieces that look like standard deviations of each. Okay, I just had to make up for the fact we're not going to use this. I just wanted it up on the screen for a while. Now, what are we going to do then? Does everybody have their calculators? You need to borrow one. Calculator. Do I have mine? Yes. So, to be really honest, as I stand here, I cannot remember if I put the calculator guide up on Canvas. But this is an excerpt from it, and it actually tells you all the steps for doing these kind of problems. So first thing I want you to do, I did the beers versus the grades here. So this is going to end up looking like one of these two. I just don't know yet which one. So let's take a minute and put this into L1 and put this into L2. So I'm just recreating my XY table in my data list. If anybody needs any technical assistance, let me know. Do you think you ever want to sort these things? We'll talk about that in a second, I guess. So for example, I mean, if I sorted the grades, why would that be incredibly bad?
Change what it correlates.
Yeah. Each row is a person. If I sort the grades, I'm putting somebody else's test grade with somebody else's beer amount. So then the data doesn't make any sense anymore. So never sort any of this. Otherwise, you'll always get straight lines, right? Okay, now, so we got the data in there. so first thing we need to be able to do. And this is something I think we did like in the second chapter at some point. We had to create scatter plots. So we're actually going to have the calculator create this. This is a freaking graphic calculator. I just fed it some XY points. It should eat that up. Yes? So what I want to do, I want to make a graph of data. I want to plot data. I want to plot my statistical data. So where do I want to go? Stat plot, holy shit. So see right above y equals, hit second y equals. Okay. Does anybody have any of those that say on?
Yeah.
All right, let's do this. Everybody hit 4. Enter. Okay. So now come back in, second y equals to go to stat plot. Now everybody's got that. Looks just like that, yes, or something like that. Some of your options might be different. Okay, so let's.
What did you say?
Sorry.
What did you say? You did?
Number 4.
Yeah. Like, make them all like turn off.
Say again. Sorry.
Like how do you would say what I'm go on?
Hit 4. Enter.
Oh, okay.
Now hit second y equals, and everybody should be off. Like, so let's all hit the first dude. Just hit enter on the first dude, and we want to turn this one on. So just hit enter, and now you can all get angry with me, but hey, it's your calculator. Do you notice what you could have made?
Bar graph.
Ooh, bar graph. Right? Histogram, right? What else? What is that one? What is the little candy looking one? Box and whisker. Oh, it's too bad. Oh man, I feel like I want to be an asshole today. All right. Okay, so everybody stop crying. So everybody, let's pick scatter plot. That's the first one. My X's are in list 1. My Y's are in list 2. You get to pick what symbol you are today. I am always a square, obviously. You could be positive. You could be a big speck of dust in the universe, or you could be a small speck of dust in the universe. That just puts that symbol on all the data points, right? And then me, some of you guys can do this too. You can pick a color. I'm going to make mine green, just because. Now watch this. If I hit graph right now, let's see what we get. I got parabolas in there. All right, this is dumb. This is not what I expected. I expected to see a bunch of dots, correct? All right. So this calculator costs enough money. If I tell it to, it should be able to go find my stuff. So everybody's picture probably looks different, yes? Nobody probably has that parabola because I put a parabola in there. If you hit zoom, and then which zoom option do you think I want?
Zoom out.
No.
Zoom in.
Nope.
Z-box.
Nope. Keep going down.
Okay.
It's going to be really obvious. No. What about zoom stat? Zoom stat. So if you go to zoom stat, it'll find your data. All right, let me know if you have issues. Everybody got that? Everybody does? Yay! It's a new one on
Wait,
me.
it says
What's it say?
dim mismatch.
That means your lists didn't end up being the same size.
Okay.
So go back to your lists. Stat.
Goodness gracious.
Hit enter to quit.
Oh, okay.
Stat edit. And you lost a data point somewhere. See how they're not the same size.
This one. How do I get rid of it?
There we go. Now try it again. Now hit zoom 9.
Okay.
Okay. Everybody else good?
Woo.
Okay. All right. So that's the first thing, is just getting that. And obviously, I tried to pick data points that made it look like this first dude. Yes.
Yeah.
It looks roughly like the first dude. All right. So that's one thing, is just to get the data to actually show up. We still have the two main things to do. I still want to figure out what R is. That'll tell me the strength. And we already had a guess for it. We had -0.2 was our guess, right? for this. This shouldn't be very strong. And I want to calculate the line of best fit, that equation. All right, so all of that happens in one place. So hit stat, because I want to do some statistical analysis. Hit calc, because I want to calculate something. And then can anybody guess which one might not? Huh?
Lim reg.
Yeah, the one that's got a line equation in it, right? AX plus B, isn't that MX plus B? And of course, stats people, we just have to be different, so we're like, we're going to use A instead of M. Okay. LinReg stands for linear regression. So that's the idea that if you have a mean, in this case a line is your mean, and then you expect your data points over time to regress to it in certain situations. So linear regression. Notice that there's this option. What is the only difference between 4 and 8?
That word X is
Yeah, what's the slope in 4?
positive.
No. What is the slope
I
in
don't
the
know.
equation in the fourth one? You guys remember?
AX.
A is. A. What's the slope in number 8?
B.
B. It's dumb. It is really dumb. TI won't tell me anything. They won't tell me anything because they think I'm from some other company trying to get information. So they won't tell me why they have both of those hardwired. I just always use 4. All right, so everybody hit 4. Now what's wrong with mine here? Where's my X's are in list 1. I gotta change my Y's to list 2. I don't have a frequency list. We're not gonna worry about this at the moment. So make sure it's L1, L2, and then go down to calculate. Let's see what we get. I probably got more than some of you did. Nah. Did anybody not get as much information as I did?
Yeah.
Let's do that. No, all right, I'll show you. There's one thing that I know you don't care, but real quick history. The older TIs, you could turn this option on and off to conserve computational power. Why they still have it now with the freaking computational power this stupid thing has, I don't know. So we're going to change something and you never have to worry about it again because it's not going to affect any of your calculations. So everybody that does not have R showing up, do this with me. Hit second 0. Now what this magical thing is it's a catalog of every frickin' function the calculator has. What's that very first one, do you think?
Abs.
It'll work out your abs. You didn't know that. No, what do you think it is? Something mathematical. Absolute vodka. No, absolute value, right? Okay. So anyway, we want to go, and again, you're never going to have to do this again if you've got your own calculator. We want to go to the D part of the list. So do you see how there's the letter D right there above this button? Just hit that button. It's already looking for a letter. So I'm going to hit this button, bam. Now I should be in the D part of the catalog.
Did you do green first?
No,
Okay.
it's already set to look for a letter.
Okay.
Is everybody with me that needs to be?
Yeah.
I've never played around with the day of the week thing. I have no idea what the inputs are. But it would tell you, if you input a date or something, it would tell you if it was a Tuesday or whatever. I think. I don't care. I want to go down to diagnostic on. And then you hit enter. Enter. And that is the most anticlimactic thing ever. But now, if you go back to stat, calc, number 4, you should have your R show up. Okay, all right. So our guess was -0.2, and it's actually -0.34 roughly. That's pretty good. So we knew it was going to be kind of weak. It should have been closer to 0. It definitely still had a negative trend though, so I knew it was going to be negative weak, which relates to negative small. Okay, I like it. I like it. Now, what's the line of best fit? What's the equation of the line of best fit? Where'd my other dude go? There he is. Too bad. So let me see, sorry. R is negative 0.339. How do you feel about that? Do you think it's a strong correlation?
No.
No. We're going to get a little more formal about this, but for right now, we'll just say, just looking at this, it's definitely not a strong correlation.
Wait, you got R equals negative point?
0.339, yeah.
Oh,
Uh-oh. What'd you get?
0.355.
Uh-oh. Yeah, one of your data points, if you go back to your list, I'll bet you anything one of your data points is not quite right.
Okay, I'll check it out.
Okay. So like, just to let you know, I forgot where I was now. Let me think. Just to let you know, on a test, when you're doing this kind of problem, what I'm gonna need you to do is you're gonna have to bring your calculator up to me, and you're gonna show me the data points, you with me? And the line of best fit, so we still have to talk about how to get that to show up. Yes, you're gonna show that to me.
Every question?
No, there's only gonna be one of these bad boys.
Oh.
Yeah, trust me, all right.
Okay.
Yeah, you don't want a bunch of these. And I can normally catch pretty quickly if you put something in the list wrong, so that's not gonna be like a major loss of points if you just input data wrong. Wait, okay, now I remember where I was. Stat, yeah, can you bring this back? So, my line of best fit, so it's weak negative. Right, that, what kind of correlation is? Very weak negative correlation. Somebody help me out. What is the line of best fit? Y equals what?
Negative 2.535.
Good start.
Keep going.
Yeah.
0.37.
No.
Oh.
AX plus B. So you told me what A is.
Oh.
That's the slope. X plus B. What happened? You got to put it together, correct? Line. Is everybody cool with MX plus B? Remember good old MX plus B? I like it. Like some of you guys are like, no, but I'm just going to do this. So AX plus B, same thing. They just tell me A and B separately. So we just have to put it together in the equation, right? Remember those problems in algebra? Find the equation of a line that goes through these 2 points, and you figure out M, and you had to figure out B, and then you threw them in there. Okay. Now, let me show you the direct way to do this. How do you think I put that into my calculator? It's going to be crazy obvious.
Put what into your calculator?
That equation. I'm going to put that equation into my calculator. As my calculator gets bored of me.
Stat.
So what? Read that equation to me. Somebody read the equation to me. What's it say?
Negative 2.
No. You have left something out.
Y equals?
Y equals stop. Okay. So isn't there a Y equals button right there? So if you hit Y equals, you can put in, I'm going to take my parabola out of here. If you hit Y equals, you can put in the equation. Be really careful. There's a negative button, right? Negative 2.535. Does anyone know where the X button is?
By the stove.
Good. Well, no, it's right up here by the alpha. Right there is your general variable button right there. That's the one you want. And then what was it? Plus 89.83. Okay. Does anyone remember if I leave the X out, I'm going to get Y equals to a number? Does anyone remember what Y equals a number looks like if I graph it?
Straight line. Horizontally.
There you go. Okay. I was going to say they're all straight. Yeah. Right? It's just a flat because it's going to be right at that level. So that's what happens if you leave X out. Now just hit graph because it's already set to look in the right place and you should have this happen. Woo!
Wait, would you press?
Graph. Once your window is set, you can just hit graph and come right back to the same window. So when do you have to hit zoom 9, zoom stat, when you put new data in?
So
That'll make the calculator kind of find it.
keep this on the test, this little instructions, or are we going to memorize it by then? Or
I hope you will,
Game plan.
because you
Okay.
can't use the instructions. You have to do this and then show it to me.
Okay.
I like it. Now, and this kind of, let's see how good I was. I took a guess. Oh, I sucked pretty bad. Well, I think it's a little bit, orientation's off a little bit, but I still kind of suck. All right. Let me just ask this to you. If you use this line of best fit to make a prediction, what does that mean? What if a student says, I drank 2.5 beers. Do you see 2.5 beers in here? No. If you put 2.5 right there, because isn't that what X represents? Would you trust the number that this equation gives to me?
No,
What part of this tells me I would not trust it?
'cause it's weak.
It's weak. Some weak sauce. Get this shit out of here, right? So the closer R is to 1 or -1, the more I will trust the line. So that's the one thing I want to do in a bit, is to formalize that. What does R have to be so that you can trust the line of best fit?
Far
That
away.
number will change based on how big your sample is. Does that make sense? The smaller your sample, the more evidence you need, the bigger R has to be. The bigger your sample, it can actually get pretty small and still be evidence that there's a linear correlation. Linear correlation, okay. What if I? You guys, now please, do this problem entirely on your own. Maybe I should get ready. Scheiße. One silly little thing I want to tell you. As you are putting data into the second column, every now and again you should stop and just look to make sure 75 goes with 10, 75 goes with, do you see what I'm saying? Because what sucks is you get all the way to the end and the lists aren't the same size. But that sucks. Where am I there? No. So, how should I graph this one? What's the series of buttons I should push right now to make sure the graph shows up correctly?
Zoom 9.
Yes, I got new data. I should zoom in now. What might happen? Let's see. Yeah, see that line? That's the old line, right? That's the old line of best fit. So let me go kill that. Okay, so let me stop here for a second. This is what it should look like for you. And that was my attempt to capture, I forgot. I don't know what that is. I must have taken out the outliner. I don't know what that is. Yeah, I think that's what it is. That's what the outliner. Okay. So is that what you guys got there?
Yeah.
Roughly right? Okay, so now we can do all the calc. Go ahead and calculate, don't say it, calculate your line of best fit, calculate your R, and then get your line to show up. guys. Oh, yeah, okay, so let me show you this. So, real quick, let's write down R. How do we feel about R this time? Did you guys get 0.737, blah, blah, blah? So 738 roughly? Yeah, okay. How do we feel about that?
Great.
Pretty good. Is it strong?
Yeah.
It's stronger for damn sure. So, on a test, let's see if you guys get this stupid joke. On a test, I'm not going to give you an R value that you have to come up with an adjective for, like you're a wine connoisseur. Little hints of strength. So I would give you an R that was like 0.98, or 0.95 or something. Obviously strong, or 0.4, obviously weak. Yes. I'm not going to give you 0.7. Like sort of strong. Every other day, So this is a little bit freaky, but I would call it decently strong. Semi-strong, whatever. So what kind of correlation is it? Is it positive or negative?
Positive.
Positive. Makes sense, it's got an up slope. Positive, strong correlation. And let's see, you guys got the line of best fit written down? Here's what I got. Roughly. So you guys got? Yes, okay. So real quick, I just want to show you one little other thing. This is not a major, crazy, awesome thing, but you can hit y equals and put it in, right? So let me show you that we can do it just like we did a second ago. Or when I do the test, do you see right here where it says store regression equation? Sound like a regression? I don't know what it is. Store the regression equation. You don't have to do what I'm about to do, right? Just in case you're curious what the hell this meant. I want to tell it to put it into y1, yes? Y1 is a variable, yes? You see where it says vars? Variables, y variable, function, y1. So if you wanted to, you could do that and it will put it in there for you, yes? Or you just put it in yourself, who cares, right? So let me just show you what it does. It goes a little crazy. So I'm going to hit y equals now. Oh my God. It just doesn't really round. Yes? So now if I hit graph, we should all get this. And that's a good illustration of, it's a lot stronger than the one we just looked at, but it's still not very strong. I mean, right? So it's sort of like in that middle, semi-strong kind of state.
Wait, mine doesn't look like that.
Right. Oh, so you got the wrong slope in there. Let's see. But you got a negative in there.
Oh, I didn't figure this was out.
Was that from before?
I think so. How'd
Yeah.
you get there?
Y equals.
Okay,
Now
let's
hit
clear.
clear and then put this one, yeah.
Got it, thank you.
Sure. Oh, get y equals. Yeah, you gotta put the equation. So I kind of skipped that part right now, but put this in there. I did it the other way, but you don't have to ever do it the other way. So let me go back and do it the manual way. So I can just go here and I've got it written down. I just have to put it 0.657 x plus 70.967. It's rounded a lot more, but to my eyeballs, looks the same. For us humans, it's the same damn line. How many data points does that line go through, it looks like?
One.
Maybe one. Right? So your line doesn't have to go through any of your data points. The same way that your average doesn't have to equal any of your data points. Correct? Same way. I like it. Okay, so last thing I want to show you. What do you guys think about this? If you use this line of best fit to make a prediction, would you trust it? Would we trust this one? We didn't trust the last one.
No.
Would we trust this one? What did we say about the correlation? What was it?
It's decently strong.
So yes, I will trust this.
Oh.
Yes. Sorry. So, again, I should have brought this with me. There is a table. I'm not gonna make you use the whole table. So on a test or a quiz, I would tell you in this kind of problem, I would say R must be bigger than 0.456 or whatever. And again, that number is based on the sample size. A big ass sample size could need R to be greater than 0.3. A tiny little sample, I may need R to be greater than 0.8 to show evidence. This one would definitely be fine. So, what if I studied for 11 hours? Could somebody predict what my grade would be? We can. I don't want to just let you do it and then I'll show you a shortcut. In this problem, what is the x variable? What is the y variable? What does it mean? Physically, what is the x variable?
Hours.
Hours, right? In our XY table, x's are hours, grades are y. So if I have 11 hours of study, where do I put 11 into my equation?
X.
In the x. And then I'm going to get a y output, and y stands for grade. So I'm just going to do y equals 0.657 times 11 plus 70.967. 7. What's this? Is that right, Jen? No, I'm not done. Give me a second. 7.2, so I think it's 78.2.
Yeah, well, 194.
Ye
Just
of
do
little-
better next time.
Ye of little faith. 78.194, right? So we got.
Yeah.
So here's a shortcut, real quick. I mean, that's plain old algebra that, you know, it's been a while since you've gotten, but inputs and outputs. When I have an XY table set up, I know what the inputs mean, I know what the outputs mean. So I can put the number in the right place. The calculator has got the equation in it. So watch this. If you go to graph, if you hit, see where it says calc? So this whole first row is all about graphically. So I want to calculate a value graphically. The value for x equals 11, 78.194. Chunkable. So I hit second, trace to go to calc. And I want to calculate the value. When x is 11, what's the output value? 78.194, which is what we got. Yay! Okay. All right. Jeff got the vaccine for the flu yesterday, and I'm not feeling the greatest, so I don't mind stopping it right there.
All right, then let's do that.
I got so much vaccine coursing through me, I expect to get some superpower sometime. But, yep. Hey, white. So you got your, oh, you did the store thing. Then hit zoom. 9 for stat. Yep. Oh, let's see, go to. Let's see, go to. I bet you in, bet you. It's gonna be another Y that has stuff in it. Yeah.
Oh, okay, there
It's
you
got
go.
some weird shit in there. Clear it. Now it'll have no problem. Hopefully, unless there's some otherwise. Bam! Okay.
Because I kept on doing it, that's what.
But whenever there's an error and there's a go-to
Oh,
option,
okay.
it'll put the cursor
Makes
on the
sense.
problem.
Gotcha.
Yes. think that's true, to be honest, because you turned in some other stuff that I don't think I put in the computer yet, so don't freak out.
I was like, I
Yeah.
have it, it's in my folder.
Now that you say that, you have it?
I might have it, some of it.
I think I have some.
I'm sure that I have at least a little bit of it, because I was like, there's no way.
You mean like I graded it and gave it back to you?
Maybe?
Because I do have a stack you gave me that right when you said something to me right now, I was like, I don't think I put that in the computer yet.
Because I know for sure that I like turned in basically everything. That was like for chapter 2, right? Kind of.
Huh? Test 2?
Yeah, for the second time.
Yeah. Well, it's for the probability quiz and
Yeah,
test 2. So I'm almost certain that I got a stack of stuff for you that I just never got to count in the computer.
Yeah, I have everything except for like, so I guess it must be here, because I know that I did it, I was not.
I got it, no
not-
worries. I just, I kind of did a rush job getting that stuff together today, but, so I didn't get all my stacks of homework at the computer yet.